Okay, question 10. Question 10 gives us the second derivative of a function, and it also tells us what the critical points of the original function are. Recall from your previous calculus course that critical points are locations where f prime of x equals 0 or f prime of x does not exist and the point is in the domain. Of f of x. So there are points that could be max or min. Recall also that f double prime of x being positive tells us, I'll call it f double prime of x at a. F double prime of a being positive tells us that f of x is concave up at x equals a. Concave up is a bowl facing up, has this shape, and we have a critical point at a location where the function is concave up, then that critical point is going to correspond to a minimum. And f double prime of a being negative tells us that f of x is concave down at x equals a. So concave down looks like this. Critical point there means it's a max. So this question is asking us to do the following. Diagnose each critical point by evaluating f double prime of x at the x coordinate and inferring the concavity. Okay, so first critical point, we're going to plug in 2 for x. F double prime of 2, we're going to have 3 times 2 minus 3 divided by 10 minus 4 all cubed. So 3 times negative 1 over 6 cubed. And what matters most is what comes out of this is negative. That means f of x is concave down. So that means 2,7 is a max. Okay, second x coordinate, we'll plug in 5. So 3 times 5 minus 3 over 10 minus 25 all cubed. So we're going to have 3 times 2 over negative 15 to the power of 3. That's something positive on top divided by something negative on the bottom. Something negative 15 cubed means negative 15 multiplied by itself 3 times. So the first 2 multiplications give you a positive, but then the third multiplication gives you another negative. Positive over negative is negative. So concave down again. So 5 comma 7 is a max. And then f double prime at the last number, -5. We're going to have 3 times -5 minus 3 over 10 minus 25 all cubed. So this time we have 3 times -8 over -15 cubed. Something negative on top divided by something negative on the bottom is positive. That means concave up. And then from that we can conclude that -5 comma 7 is a min. I'm going to add the bowl shapes, the concave up and concave down. Okay, number 11 is asking us to find the critical points where we're not actually given the function, but we're just given the derivative of the function. So to find critical points, we're going to set f prime of x equals 0 and solve for x. So 7x times x squared minus 9 is equal to 0. We want to get all the solutions, so I'm going to factor. X squared minus 9 is the difference of squares. It factors as x minus 3 times x plus 3. And then that tells us there are 3 solutions. One solution if 7 times x is 0, which means x equals 0. One solution if x minus 3 is 0, which means x is equal to 3. And one solution if x plus 3 is equal to 0, which means x is equal to -3. And those are the 3 critical numbers. Just going to highlight the conclusions. Okay. Question 12 asks us to use the concavity test, which was the test used in question 10, to determine the xy coordinates of some of the local max and local min. So step 1, check for critical points. That means f prime of x is equal to 0. So I'll check for that. Change my color coding. Okay, so looking for f prime is equal to 0. I see f prime of 3 is equal to 0. I see f prime of 10 is equal to 0. And I see the other ones, the derivatives are not 0 there. Okay, so f of x has a critical point at the x coordinate 3, comma, the y coordinate 7. The 7 comes from f of 3. Okay, and f of x has a critical point at 10, comma 0. 0 because f of 10 is equal to 0. Once we've determined which points are critical points, we're going to use the second derivative test to diagnose them. So diagnose each critical point using f double prime of x. F double prime at 3 is equal to 6, which is positive. That means concave up, which means a minimum. f of x has a local min at that coordinate at 3, 7. And we check the second critical point. F double prime at 10 is negative 3, which is negative, so concave down. And that means f of x has a local max at 10, 0. All right, question 13. So suppose f of x has a local max at x is equal to 3, a local min at x is equal to 5, and neither a max nor a min at x is equal to 4. Match the statements about the derivatives of f of x that are consistent with this data. So I'm going to start with f of x has a local max at x is equal to 3. Means f prime at 3 is equal to 0. There's another possibility that f prime of 3 could not exist as long as 3 is in the domain of the function. That's another way you can get a critical point. But all the options, all the statements on the right-hand side, they all involve the derivative being 0 or not 0. Okay, so that alone allows us to eliminate some options. Option C says that f prime of 3 is equal to negative 5. And I'll highlight the part that, I'll further highlight the part that we can, okay, so we can get rid of that option because f prime of 3 is 0, not negative. It has to be 0. And max means concave down. So f double prime at 3 is equal to negative. The second derivative being negative means we can get rid of option A. So option B must be correct. Okay, next point. Local min at x is equal to 5. That means that f prime of 5 must be equal to 0. So looking at the options that are here, I should do some more color coding. Okay, so looking at the options that are here, let's see, D has, looking at G now. G has f prime of 5 is 0, H has f prime of 5 is 0, and I has f prime of 5 is equal to negative 3. So we can cross that one out. Can't be I. Okay, and min means concave up. Concavity is a property of the second derivative, so f double prime of 5 must be positive, concave up. So looking at the options that are there, we see G has f double prime of 5 is equal to negative 5. So H must be the one that's correct. It's the one that's consistent with the statement. Second derivative is positive, first derivative is 0. So it must be H for x is equal to 5. And then neither max nor min at x is equal to 4. Oh, forgot to eliminate G there. Okay. F of x has no max or min at x equals 4. Is consistent with f prime at 4 not being equal to 0. So that would be option D. As a warning, if f prime of x equals 0, well, let's make it general, make it specific, I mean. Let's say f prime of a is equal to 0, and f double prime of a is equal to 0, then the concavity test is inconclusive. But we do not have this type of option. If we did have such an option, it would be a potential consistent statement. Okay, and I'll continue the other questions in another video.